In the previous videos in this section, you drew shapes into the UI view's context. In this video, we'll explore how to create images using a context on the fly. We'll also look at how to do clipping masks in Core Graphics and a couple of other drawing tricks. During DrawRect, you have access to the UI view's context. You can directly access this context using UI Graphics getCurrentContext, which returns a CG context object. Once you have a handle to the context, you can do things like fill it, create a clipping area or a gradient, and later on we'll see how to scale and rotate the context before drawing into it. As you can see from even this bit of code, there are a number of ways to do the same thing in drawing. Here I've used context.fill. I could have used UIRectFill or created a UI Bezier path and filled the path. Core Graphics is one of the oldest APIs in iOS, and it's been through a lot of evolution. The methods on CG Context are C code wrapped in Swift. Apple seems to be gradually adding to UIKit to replace the CG Context methods. For example, this shows two ways to draw an image into the view. You can use context with the CG image property, or you can use the UIImageDraw method. These are equivalent. Talking about images, with UI views, you have access to the view's drawing context during DrawRect. But UI image views are different. They're highly optimized for image drawing, and the system doesn't call DrawRect. So if you've loaded a view controller that has only UI image views, and you want to generate some dynamic images, how do you get a drawing context? The answer is that you create an image renderer. This is an object that will automatically create a UI Graphics image renderer context object, which you can draw in. This context is the UIKit evolution of a CG context. You can still access the CG context underneath if you need to, as we will for scaling cupcakes. You set the size image and then use the renderer image property with a closure to do all the drawing in. The code here creates a red rectangle in a context, just as in the previous slide. However, this code returns a UI image that you can use in image views or buttons or wherever you need a dynamic image. We're going to move the cupcake drawing out of DrawRect and into an image that will draw in layout subviews. The advantage of this, aside from abstracting away the image building, is that the image will only be drawn on change of layout. If you're doing a lot of drawing, writing it out in code is very cumbersome. There's an excellent app called PaintCode from paintcodeapp.com, where you draw your shapes and it changes it to code. This is the PaintCode file where I drew a cupcake. You can tell I'm not much of an artist, but you can draw lines and curves, and it's just like using a normal vector drawing app. The great thing about PaintCode is that it automatically generates code, and you can see the code as you're drawing. We'll have a closer look in a moment. We're going to use the code from PaintCode to draw the cupcakes in the rating control. We're going to draw an image 4 times and mask it with red and white cross-hatching.
Open up preview.storyboard and option-click ratingview.swift to show it in the Assistant Editor. I'm going to temporarily convert Rating View into a UI Image View and show you how to draw the cupcake from Video 2 into an image. Using an image view means that DrawRect won't be called, so we'll have to set up an image renderer. First, I'll change Rating View to be a UI Image View. Notice the cupcake disappears because DrawRect isn't being called anymore. I'll create a method to draw the cupcake and return an image. And now I'll set up the renderer with the correct size. And set up a closure to create the renderer image. So all the drawing code for the image is going to go inside this closure. I'll cut all the drawing code from DrawRect and paste it inside the closure. And I'll call the drawing method from Layout Subviews, which is where we have the Views bounds, and I'll set the UI Image Views image property from Draw Cupcake. And now we have an image of a cupcake which we can use anywhere we want. However, our rating view is going to be a bit more complex, so I'll revert the image view back to being a UI view. I'll need to create a specific image property as UI view doesn't have one. And the image isn't being drawn anymore automatically, so I'll draw it in DrawRect. Let's have a brief look at Paint code to see how we can get a better drawn cupcake. Here's the Paint code file that I drew. Paint code is just like a regular vector drawing program. You create a canvas and then you draw. As I draw, Paint code creates code for me, and I can then export this code to Xcode, or I could just export an image in various resolutions if I prefer. Paint code is a really great way to learn core graphics as well, because as you draw, it shows you the code. Back in Xcode, open up utility drawing.swift. This is code that Paint code generated, and then I altered it to return a cupcake image of any size. You can see that it's the same principle as our image drawing method. There's just a few more paths in there. Instead of using our drawing code in DrawRect, we'll use this Paint code. And that's a much better looking cupcake. We can get rid of this drawing code now. The ratings control is made up of a few different elements. We'll need a red background masked by the shape of a cupcake. On top of that, we're going to have a crosshatch pattern made up of diagonal lines. This is also masked by the shape of the cupcake. Let's have a look at drawing the crosshatching. We're going to take the same approach as for the cupcake. We'll create an image using the graphics image renderer. Let's set up the variable for the image and do the drawing code directly here. So far, that's standard code. Let's set up draw so that we see the cross as well as the cupcake. In the closure, we can access the context through context.cgcontext. CGContext has a nifty method that UI Bezier path doesn't have to draw multiple lines at once. You pass the points in an array. Here we've set a path directly on the context, so to do the draw, we tell the context to stroke the path. And the add lines method has drawn 2 lines. For our cross, we only needed the diagonal, but I wanted to show you how an array of points can make up the lines. And now we'll do the other cross. Now that we have an image for the cross, instead of drawing it once, we can draw it as a pattern. So that's covered the whole view with the cross pattern. Let's set up the background red colour and change the cross to white. This code here is equivalent to uicolor.white.setStroke. We want the crosshatch to be masked by the cupcake shape. We can do this in two ways. If we had a path in DrawRect, we could make it a clipping path with path.addClip. But currently we're working with images, so we can't do that. But the cupcake image is transparent, so we can use that as a mask. So in DrawRect, we can get the view's drawing context and mask the context using the cupcake image. So here I've got the current context and I've clipped the context to the outline of the image. Just occasionally when using CG paths and CG images instead of UIKit, you'll suddenly come across situations where things turn upside down. This is because Core Graphics is an old technology and predates iOS. On OS X, the origin, that's where point 0 is, was at the lower left. But when UIKit came along with the iPhone, Apple decided that the origin is at the upper left. So a UI image has its origin at the top left, but a UIimage.cg image has its origin at the bottom left. The usual answer to this is to try to use UIKit and not CG images, but sometimes the CG commands are a better or even an only choice. The way to counteract our current problem is to flip the context before drawing. If we turn the drawing context upside down and then draw, it will appear the right way up in the view. We'll go through how to do that in the next video.